the 7th and 8th grade go out to the preserve, and we do monitoring at the preserve that correlates with what that grade is learning in science that year. So in science, in the 7th grade, they monitor bug and fish species and amounts, stream flow, and groundwater data.
And the 8th grade measures water quality and water chemistry data at the preserve, as well as air temperature and precipitation levels. This graph we've been working on for the past 9 years, and it shows a comparison of the stream flow data and the groundwater data we've been collecting.
So our stream flow is the blue line, and our groundwater is the red line. We measured our groundwater in average centimeters below the level line, and we measured our stream flow in cubic feet per second. Our stream flow fluctuation, and usually when we go out to the preserve, we get an average between 0 and 8. Our groundwater, we've been noticing a trend of seasonal fluctuations. So in the growing season between June and September, we see that every time the groundwater drops.
One of our goals when we started this project was to see if the stream flow and the groundwater level connect. But while the groundwater fluctuates, the stream flow doesn't change a lot. Until in February of 2008, the beavers came. And we also, these green dotted lines represent when we took the Russian olives out. At the end of here, we had taken 14,000 Russian olives out of the preserve. And because we thought that it may have to do with the ground level, and because the Russian olives take out a lot of water. But since the beavers came at the same time we had taken out all the Russian olives, we don't know if the reason for the increasing groundwater level has to do with the beavers or with the Russian olives. But in the end, because this red line represents the beavers being there, when the beavers left, we can see that the groundwater level drops again, and it continues fluctuating like it did before.
Once we had the beavers for a long enough period, we could see that when the groundwater was filled, that groundwater and stream flow here, as you can see, start to correlate more. And so as the stream flow and groundwater fluctuate at the same time, basically. So this is one of the benefits, we think, of having a wetland area, is that once we fill up the groundwater, it can be that there's going to be more water for to go downstream.
Now what? I think I want to tell you a couple of other projects that we're working on. One of the pieces of data that we just started collecting this year is we found these dendrobands, and we're putting dendrobands on several of the trees. We have 11 trees that follow the well line, and you guys want to talk a little bit about what dendrobands do?
So this is what a dendroband looks like on a tree, and it measures the diameter of a tree in centimeters.
So we see the most increase in growth of the diameter of the tree in the springtime when the tree is taking in the most water when it's growing. We don't see that much change in the winter because it's not growing and it's basically asleep.
We just think this will be really interesting data. It's going to hopefully show us influences of precipitation and climate change over the long term. So it's a new thing that we're doing. And the last new thing that we're working on is changing the herbaceous understory. We thought when we got rid of the Russian olives that that's kind of a typical restoration project. you finish with that and then you're done. We saw lots of responses to the removal of the Russian olives. Many new species began to come in. We found northern leopard frog. We have a photograph of a southwest willow flycatcher, marsh wren nesting, some other things that are unusual and uncommon, and we thought that was great. But we are also interested in what would happen if you could get rid of the tall fescue and the cheatgrass and the thistle that are up there. So that's our latest project, and so we're pulling lots of tall fescue and planting native sedges and grasses, and so we'll see what happens. But that's our project, and we'd love to take questions, especially about the stream flow graph. Claudia?
The beavers not being there anymore, my understanding is that they're still there. Maybe you guys are talking about a certain place.
Yes. Anybody want to say anything?
The beavers are still in this area, but we're talking about our project preserve down in La Cienega, and there's just the area of land that we have. And so that's where we saw the beavers, and that's where we collect all this data.
Yeah, and the beavers are now upstream from where we are. So they're still there, but they're not in our specific area, so.
Yes.
Could you comment on how you gauge the river? How you gauge the stream?
Do you guys remember?
Well, the stream flow, we test how quickly it's flowing through a 10-meter section
Yeah.
to measure this. We look at how deep the water is and then how quickly it's flowing to get the cubic feet per second for stream flow. And then the groundwater, we have 11 wells all the way across the preserve, and they're all at a certain level line. And so we measure how far below the level line the water is for each of those wells. And then we average that data to get how many centimeters below the level line the water is in a day.
So each one of these points represents 11 wells. And the stream flow method, we use Rich Schrader's method that he has taught us with so we measure width and depth and over length and the time it takes a float to get by. So, yes?
Did I hear what you say you were also measuring water quality as well?
Yes.
What parameters do you look for?
Well, the 8th graders measure nitrate, dissolved oxygen, pH, phosphorus, turbidity, TDS,
Temperature.
and water temperature. So those are the main qualities we measure for the water to see.
Have you seen any changes in water quality?
Okay. I know for the nitrate and phosphorus, the levels have been peaking during the winters. And for nitrate, the wastewater treatment plant, which is upstream from our preserve, is regulated as to how much they're allowed to release downstream. So it has been below that regulation, but it's still fairly high in comparison to where it would be naturally. And
Total phosphorus is high, and it's not regulated. So that's the one parameter that comes out high all the time. Yes.
Has it dropped at all since they've banned phosphorus from detergent?
Well, it hasn't really dropped since we've been measuring it.
It was like 2 years ago.
Yeah, we had, actually, that's interesting, I didn't realize that. In the first couple of years, we've been measuring phosphate for about 4 years now. The first couple of years, we did have a few spikes where it was as high as 12 milligrams per liter. And in the last couple of years, the highest we've gotten, I think, is 4. So it's still way above what the recommendations are for a cold water fishery. Of course, it's not a cold water fishery, but we don't have any other recommendations, so that's what we think.